So, in this video we are going to talk about the Liouville Theorem. But first, what is the phase space? I may have already said it, but repetita iuvant. So, the phase space will be a 2s dimensional space, where s is the number of degrees of freedom, where on the x-axis I will have the positions and y I will have the momenta. Of course, now in this way would be a one-dimensional system, but it's the easiest way to draw it. And each particle in the system can be represented as one point inside this phase space. And during time, these points will move during a certain phase path. Now, the interesting thing is seeing how the points in general, what's inside this phase space, behaves under canonical transformations and thus in time. Because as I have said in a previous video, the evolution of a system in time can be considered a canonical transformation. A simple, very simple example of canonical transformation. So what does the Liouville theorem say about this phase space? A closed and insulated system. So there should be no external field, no external force, whatever. Otherwise, the Liouville theorem won't be valid anymore. Now, if we do an integration over all the points in the phase space, so over all the positions and all the momenta, what we will get is a volume. So if we integrate through the whole phase space, all the positions and all the momenta, what you will get is an integral of volume. And this is the volume of this phase space. What the Liouville theorem says is that this volume is a constant. So what does it mean? It means that it won't change in time and it won't change under a canonical transformation. So whatever canonical transformation I do, or whatever kind of amount of time I might wait, this volume will remain constant. The same thing could be said using the density. So you would create a linear density of these points. Of course, it makes only sense if you watch it from far enough, because they are single points. It's not a true continuum. But if you treat it as it was a continuum, you will see that the time derivative of the density will be 0. So, from these two different ways of expressing the same thing, so the Liouville theorem, what we get is that in a closed system, the phase space acts like an incompressible fluid. So it will never change its density or its total volume, but it can only change its form. This is a big insight in the time evolution of a system, because knowing these conditions, you can more easily understand how the system might behave and might act. You will probably encounter the quantum version of this theorem when you're going to go on in your studies in physical chemistry.